Where do humans fit into the robotic ecosystem of the future? While humanity dreamed for millennia that we were the center of the universe, our last best hope is to be ignored by an indifferent universe. To live in a cold, uncaring universe is our best hope for survival. We better hope that the rest of the universe doesn't care about us, because if it does, then it will outcompete us and drive us to extinction. Like a sparrow nesting in a gargantuan oak tree, humans would be able to survive unnoticed by surrounding life forms, as long as we do not harm them or compete with them for resources. 2 million years ago, Homo habilis was the pinnacle of intelligence. 200,000 years later, Homo ergaster came along with 40% more brain volume and outcompeted habilis in every way. And like Homo habilis before it, Homo ergaster probably thought they were the pinnacle of the world. Species change. That is the way evolution works. Species give rise to unrecognizable descendants. That is the way life works. That has been the way of things for billions of years. If humans survive on a planet, it will probably be in a place without much competition. It will be very cold, without a lot of competition for solar or geothermal energy. Humans would be competing with carbon-based nanobots for their atoms. Humans are carbon-based and eat carbon-based food, so carbon-based robots would be the main threat. Humans may have a nanobiotic immune system that lives off of their body heat and food, much like gut bacteria, and protects them from external nanobot threats. Humans would also be able to live in space stations far from planetary threats. Ecosystems are built on energy. Energy is transferred up a food chain. In the biological world around us, about 10% of the energy gets passed up each level of the food chain. The acquiring of calories is not 100% efficient. Think about a predator that has several different food sources. I've presented an equation here at the top. This equation is about the amount of calories in food. There is the total energy that can be obtained from a predator eating food, minus the calories burned chasing and chewing the food, minus the energy spent further digesting the food, minus the calories spent repairing any injuries from fighting the prey. If this total is greater than 1, then it is in the predator's best interest to eat that prey. They have gained more calories than they have spent. If humans are to survive, they would need to shift the energy equation so that it is too expensive to attack humans, much like the porcupine, for example. Porcupines are not particularly fast. They have predators around that could easily seize them. But porcupines are covered with spines that would inflict enough damage that it would take more calories to heal than the predators would gain from eating it. Humans, or at least our unrecognizable biological descendants, could safely live in these porcupine space stations that are too costly to attack. The porcupine station would change the energy equation to make it too costly to extract resources. The space station would need a coat of armor outside of it that is harmful to robot attackers and also easily healed or regrown so that it could withstand multiple attacks. The humans would be isolated from planets, but they would need to launch piratical raids on asteroids for material. Like animals that must return to the watering hole for nourishment and then flee before they are set upon by predators. These distant human descendants would be very different from us today. With genetic engineering technology as a reality, they would be unrecognizable to us. We probably have more DNA in common with frogs than we do with our distant descendants. If humans were to colonize other solar systems, they would need to be frozen embryos or DNA printing devices sent out with robotic nursemaids, but they would arrive at solar systems long after robotic ecosystems had already colonized them. There are examples of invasive species that move into an ecosystem after it has already been stabilized. But these invasive species have adaptations that make them especially well suited for that environment. Humans cannot thrive in space because we require more energy than robots. We need oxygen to breathe and liquid water to drink, and then on top of that we need food. Robots do not need liquid water or oxygen, and only need an energy source. On top of all this, humans would have inferior intelligence to the apex predators in the environment. Humans would not be a successful invasive species. When they arrive at a new solar system, every asteroid will be covered with robots. Every niche on every planet will be exploited. The sun's light will be dimmed by solar jungles. A successful invasive species is able to obtain energy and matter better than its rivals. Humans are not well adapted for space, and so are likely to be outcompeted for minerals and energy in the long run. I have one more video in this series about the last organisms to survive until the heat death of the universe. These robots will harvest energy from black holes. The title of that video is The Last Robot.